All right, so getting started, and we'll get through, let's see, the last class I got through number 11 today, and then we'll wrap it up on Wednesday. So that's why there's only 2 sections this week, because this one takes forever to get through. Now, remember in previous sections, we were given polynomial functions and asked to find the zeros of those functions, right? So what did we do? Let's say our polynomial function was this. And we were asked to find the zeros of this function. The zeros come from, I needed to put this in its factored form, right? Because then we set each factor equal to 0 to find the x-intercepts of this, in this case, parabola. So if I factor this and put it in its factored form, what gives you x squared here and here? Okay. And then what are the factors of 15 that add to 8? 3 and 5. So that puts it in factored form. Once you put it in factored form, those are the factors that you set equal to 0. Oh, don't need parentheses. X plus 3 equals 0. And x plus 5 equals 0. And then solve them for x, which on this one I would need to subtract 3. So x would equal -3. On this one, I would need to subtract 5. So x equals -5. So what's going to happen in this section is it's going to give us the zeros and ask us to find the polynomial function that created those zeros. So we're going to go backwards. So if it gave me the zeros of -3 and -5, what did this 0 come from? What factor? X plus 3. What did this 0 come from? X plus 5. So that's the first step, is you're going to turn the zeros back into their factors. And then how do I get from this to this? 4. Okay. All right, so on number 1, it tells me find a polynomial function of degree 3. That means at the end, once I've multiplied everything together, degree 3 means that 3 is going to be my highest exponent. I'm going to end up with an x cubed. Okay, so the zeros of this function are -3, 4, and -5. So like I said, the first thing you're going to do is turn those zeros into the factors that they came from. If this is the 0, what did it come from? X, opposite of this, plus 3, right? That's where that came from, is x plus 3, right? Because if I set that equal to 0 and solved it for x, I'd have to subtract 3 from both sides, which gives me that -3. What did this come from? X minus 4 and x plus 5. So there's all the factors, and I have to multiply all that together, which means I need to FOIL here. That'll give me a trinomial that I'm going to have to distribute to that x plus 5, right? I got to multiply all 3 of them together. So good. X times x gives me x squared. My outer x times -4 is -4x. My inner is +3x. And my last, +3 times -4 is -12. Put those together, right? Since they're like terms, I really have minus x, right? -4 plus 3. So I've got x squared minus x minus 12. From multiplying these 2 together, now I just need to drop down this factor, x plus 5. And now distribute everything. So x squared times x gives me x to the third, which that gives me a clue that I'm almost done, because remember it told me it was going to be degree 3. So which means this is going to be our last multiplying. So x squared times x gave me x cubed. X squared times 5 is 5x squared. Distribute the negative x to both of those. Negative x times positive x is negative x squared. Negative x times positive 5 gives me negative 5x. And distribute the negative 12 to both of those. So negative 12 times x is negative 12x. Negative 12 times positive 5 is negative 60. And then clean it up. X cubed, x squared, you've got 5 minus 1, so that gives you 4x squared. Your x's, negative 5 and negative 12, so negative 17x, and then minus 60. If you're looking at your handout, the only thing, it's got all that written out for you, it's just got a blank in front of the x squared, which means you just need to put that 4 in that blank. Lots of this. Number 2, write a polynomial function whose zeros include 1, 3i, and negative 3i. So we're doing the same thing. So there's my zeros. The first thing you're going to do is turn them into their factors. So if 1 is a 0, that means it came from x minus 1. 3i came from x minus 3i. This one came from x plus 3i. Now, remember, multiplication you can do in any order. There's definitely one FOIL you want to do before the other. It's this right here. These two you want to multiply together first. The reason is they are called conjugate pairs of each other. Exactly the same what's inside them, except for their sign. So look what happens every time you multiply conjugate pairs together. X times x, x squared. X times positive 3i gives me positive 3 xi or ix, however you want. Look at your inner. What's that going to give me? Negative 3 xi. Then my last negative times positive gives me negative 9i squared, right? I times I gives me 9i squared. Look at what happens to your middle two terms first. They cancel each other out, right? You've got positive 3 and negative 3 of like terms. That's always going to happen when you multiply conjugate pairs together. Your outer combined with your inner, which gives you these middle two terms, are always going to be the opposite each other, which means they're always going to cancel out. So I've got left with x squared. Now, this I squared, does anybody remember what I squared is equal to? It is the same thing as negative 1. Here's why. If the square root of negative 1, that's what equals I. Square both sides. The side is I squared. What happens over here? What do this squared and square root do to each other? They're opposites. They just cancel each other out. So you're left with negative 1. So I squared is always going to equal negative 1, which means this really says negative 9 times negative 1 which makes it what? Positive 9. So plus 9 is what you're left with. So again, the middle two terms canceled. Your I squared turned to -1. So when I multiply that times the -9 that it was hooked onto, it changed it to plus 9. Okay, a shortcut rule that you can always say, well, if I have an I squared hooked onto a number, it's just going to change the sign of it and drop the I altogether. So I have x squared plus 9 coming from this. What do I still have? Good. And then FOIL that. So x times x squared gives me x to the third. X squared, oh, excuse me, x times 9 gives me positive 9x. My inner minus x squared, and then my last -1 times positive 9 is -9. There are no like terms to combine, but I do need to rearrange a couple of these terms, right? Because you want your terms to go in descending order if they're exponents. So x to the third is up top, is first. But after x to the third, I want x squared. So minus 1x squared. And then I want my x, so plus 9x. And then my constant, which is minus 9. Now, be careful. Look at what on your sheet, what it has for you to fill in. It's just got blanks. It's got this. It's got x cubed minus blank x squared plus blank x minus blank. So it's got all those signs in there for you. What's in front of the x squared? Minus, it's already got the minus for you, right? So you're just plugging in the 1. What's in front of x? 9. It's already got the plus, so you just put the 9. Minus, what's your constant? 9. It's already got this minus there for you. So just don't let that throw you off when you're typing in your answer. Number 3. There's 2 things. These right here always come in pairs. Your I zeros always come in pairs like that with the opposite signs. So do your square root or radical zeros. So also on number 3, the zeros are the square root of 7, it's paired, negative square root of 7, and 5. Turn them into their factors. This one came from x minus the square root of 7. This one came from x plus the square root of 7. This came from x minus 5. So again, you want to do your conjugate pairs first, which are these 2 right here, right? Everything's the same, but they're signs. So what happened on the last one with the adders? Well, let's do that first. What's x times x? What's going to happen with the outer combined with the inner? Always. They're going to cancel each other out. They're going to be opposites of each other. This is positive x square root of 7. This is negative x square root of 7. They're always going to cancel each other out if they're like this. So I can essentially do my first and then do what? Jump straight to my last. So what's that going to give me? Negative square root of 49. So again, if you have conjugate pairs, you can do your first and then just jump straight to your last. So let's see, what does this give me? X squared minus, what is the square root of 49? Plain old 7. So you're just left with x squared minus 7. Bring down the x minus 5 and FOIL. So let's see, x squared times x gives me x to the third. X squared times -5 gives me -5 x squared. My inner, -7x. And my last, -7 times -5 is +35. So I don't even need to clean anything up. There's no like terms. I can't put anything together. And all the terms are in the right order. Okay. Number 4. Same thing, but now I got to throw in a fraction. My zeros are -1/2, 0, and 3. So if this is my 0, that means it came from x plus 1/2. If 0 is your 0, what is that going to come from then? Just plain old x. It would, so if I think about it this, it would be x minus 0. That's just x, right? So if your 0 came from 0, that means it just came from the factor of x. What did this one come from? X minus 3. All right, there's not any conjugate pairs, so there's not anything telling me where I have to start. Go ahead. Nope. Nope. Nope, it wouldn't. So since there's not any conjugate pairs that are screaming out, start here, I can start anywhere I want. And just because I'm lazy and want to avoid this fraction as long as I can, I'm going to start with multiplying these two together and then dropping that down. So if I multiply these two together, what's x times x? X squared. X times -3, -3x. Now I have to do x plus 1/2. So I'm going to FOIL. X times x squared gives me x to the third. X times -3x gives me -3x squared. 1/2 times x squared is 1/2 x squared, positive 1/2 x squared. And then my last 1/2 times -3x. So I've got 1/2 times -3/1x. The good thing about multiplying with fractions is you just go straight across on top and bottom, right? You don't have to have a common denominator in this situation. So what is this going to give me? -3/2x. So -3/2x is the last term. Now what do I have to do though? I do need to put these x squareds together. So how many do I have? I've got -3 plus 1/2. Now I do have to have a common denominator because I'm adding fractions. What's this one's denominator? But it needs to be 2, right? In order to add those two together, this one needs to be a 2, so it'll be the same as this one. How do I make that happen? What can you multiply any number in the world by without changing its amount? 1. So I just need to use a fancy formal one, right? If I need this to be 2, what do I need to multiply it by? 1 times 2 will be 2. What if I put a 2 up here also? What's this equal to? 1. So I am just multiplying -3 times 1. So I'm not changing the amount of it. I'm just turning it into a fraction that I can add to 1/2. So what does this end up giving me? What's 2 times -3? -6/2. What is -6/2? It's -3. So again, I haven't changed the amount of it. Now I can add it to the 1/2 though. How many halves does this give me? -6 plus 1 gives me -5 halves. Or put -3 plus 1/2 in your calculator. It's going to tell you -2.5, which means you'll just do what? Math, enter, enter, right? So if you want to put it in, it'll do it in the calculator app also. So if I'm combining like terms and I don't want to go through getting the common denominator and everything in your calculator, just put -3 plus 1/2. Enter. Again, it's always going to start off giving me a decimal. To turn that into a fraction, just hit your math, enter, enter. So there's your -5 halves. So that was putting those together. So I've got x cubed minus 5 halves x squared minus 3 halves x. Number 5. Is that the worst one? All right, so far, all the ones that I've had to turn zeros into factors and then multiply together, the highest degree I've ended up with was x cubed. Law number 5, it says find a polynomial function of degree 6. That means I'm multiplying all this stuff together, and instead of getting x to the 3rd at the end, I'm going to get x to the 6th, which tells me there's 6 factors. Okay, so degree 6 is what I'm going to end up with, and it tells me my zeros. -3 is a 0. But this time it has multiplicity 3. Zero as a 0, and its multiplicity is 2. And 3 is a 0 of multiplicity 1. Now remember where those multiplicity numbers come from. They're the exponents of the factors, right? So if this is a 0, what is its factor? X plus 3. But if this came from multiplicity 3, that means that x plus 3 is cubed. 0, so it's just x, multiplicity 2, so squared. 3 is a 0, so it came from x minus 3, and its multiplicity is just 1. So no conjugate pairs, so it doesn't matter where I start. I just have to end up with multiplying all 3 of them together. I'm going to start here, just because that seems easier. I'm just distributing x squared there. So x squared times x is x cubed. X squared times -3 is -3x squared. But here, what does x plus 3 cubed mean? X plus 3, x plus 3, x plus 3. So I'm going to do that over here. So once I do this over here, I'm going to come back over here and just put it where this x plus 3 cubed came from. So let's FOIL this. First outer, inner, last. X times x gives me x squared. My outer, x times 3 is 3x. My inner is another 3x, and my last 3 times 3 is 9. Put my x's together. So x squared plus 6x plus 9. Bring down this x plus 3. And distribute x squared to both of these. So x squared times x gives me x cubed. X squared times 3, 3x squared. Then move to the 6x and distribute it. 6x times x is 6x squared. 6x times 3 is 18x. And then what's the last thing I need to distribute? The 9 to both of these. So 9 times x gives me 9x, and 9 times 3 is 27. Clean it up by combining your like terms. How many x cubes do I have? Just that one. Yeah. Now, there's your x squareds, 3 and 6, so I have 9 of them. X is 18 and 9, which means I have 27 of them, plus 27. So where does that go? Where the x plus 3 cubed was. So what did it end up being? X cubed plus 9x squared plus 27x plus 27. Now what do? Distribute each one of these terms to both of those. Now, here's the best news of the whole problem. What is x cubed times x cubed? X to the 6th. So that means I'm on my last step because I'm at degree 6 now, right? That's what it told me I was going to end up with, was degree 6, and I'm there. I just have to do the rest of the distributing. So x cubed to both of those. So x cubed gave me x to the 6th. X cubed times negative 3x squared. When you're multiplying x's, you add their exponents. So that's going to give me what? Negative 3x to the 5th. All right, so I'm done with the x to the 3rd. Now I'll move to the 9x squared and distribute it to both of those. So 9x squared times x cubed gives me 9x to the 5th. 9x squared times negative 3x squared gives me what? Negative 27x to the 4th. So I'm done with the 9x squared. Move to the 27x and distribute it. 27x times x cubed gives me positive 27x to the 4th. 27x times negative 3x squared gives me negative 81x to the 3rd. So I'm done with 27x. I only got one more thing to distribute. This 27 to both of those. 27x cubed. 27 times negative 3 gives me negative 81x squared. And then clean it up. Are there any other x to the 6s? No, just this one. What about x to the 5ths? Let's see. Here's my x to the 5ths. I've got negative 3 plus 9, so that gives me positive 6x to the 5ths. What happens to your x to the 4ths? They cancel. Put your x to the thirds together. Negative 81 plus 27 gives me negative 54. X to the thirds. And what's left at the end? Minus 81 x squared. That's the longest one. So again, we really didn't do anything else besides distribute and combine like terms. So like I said, it's not difficult. It's just very tedious and lots of room to make one simple mistake, right? That is going to throw off the whole thing. Okay, so just take it one step at a time. All right, the next one is similar to this one, just not as long. All right, this one says find a polynomial of degree 4. So it's not going to be as long. And negative 1 is a 0 of multiplicity 3. And 0 is a 0 of multiplicity 1. So this came from x plus 1. Its multiplicity is 3. This came from just x, and its multiplicity is 1. So all I need to do is this x plus 1 times itself 3 times. And then once I do that, I'll just distribute this x to that, what's left. So let's FOIL here. X times x is x squared. X times 1, 1x. My inner is another 1x. And my last 1 times 1 is 1. Put your x's in the middle together. So x squared plus 2x plus 1. Bring down this x plus 1. Distribute the x squared. So x squared times x is x to the third. X squared times 1 is x squared. Distribute your 2x. 2x times x is 2x squared. 2x times 1 is 2x. And then distribute your 1. 1 times x is x. 1 times 1 is 1. So let's see, I'll put it up here. I'm left with x to the third. My x squareds that I put together. I've got 1 here and 2 there. So I've got 3x squareds. My x is 2x and x. So 3x and 1. And what do I need to distribute to all those? X. And then you'll be done, right? Because what's x times x cubed? There's your degree 4, right? X to the 4th. X times 3x squared just gives me 3x to the third. X times 3x is 3x squared. And x times 1 is x. So earlier, now the next 3 problems is a complete break. Everybody good? Earlier, when we had zeros, if we had the ones that came in the conjugate pairs, were always from square roots and i's, right? When we were doing those, when we multiplied the conjugate pairs together, they were always like the square root of 7 and negative square root of 7. That's always going to be the case on these. Oh, wait. Oh, yeah. So like on number 7, it says, suppose a polynomial of degree 4 with rational coefficients has the given numbers as zeros. Find the other 0. So the numbers it gives me as it gives me 3 of them. If it's degree 4, that means there's only 1 missing. So I have negative 4, square root of 2, and 5 halves as zeros. The ones that always come in the conjugate pairs are square roots and i's. So if I'm looking for the missing 0, if this is a 0, then the opposite of it is also. So if the square root of 2 is a 0, then its opposite pair also is. So the missing 0 is just negative square root of 2. That's it. Number 8. Same thing. Suppose a polynomial function of degree 4 has these zeros, negative I and 3 minus the square root of 5. So how many zeros are missing if it's degree 4? Giving me 2, which means 2 are missing. If this is a 0, so is I. If 3 minus the square root of 5 is a 0, so is 3 plus the square root of 5. Those are the 2 missing zeros. Number 9, last one like this. Another degree 4 polynomial function with the given zeros of 3 plus 5i and 1 minus the square root of 3. So there's 2 missing zeros, right? If it's degree 4. What goes with this one? 3 minus 5i. Then this one comes with its pair 1 plus the square root of 3. All right, we're going to do 2 more. We're going to do 10 and 11 and then wrap this section up on next class. So it's going to be asking me the same thing. It's going to give me some zeros. You'll have to find the missing zeros and then find the polynomial function that they came from. Which means on that last one, once I found the missing zeros, I would have turned those all into their factors and multiplied them all together. So it's just taking this one step further. So number 10, find a polynomial function with the lowest degree that has the given numbers as sum of its zeros, negative 2i and 6. What's the missing 0? Goes with this one, positive 2i. Now we're going to turn these into their factors and multiply them together to get the polynomial function that created these zeros. So what did this come from? X plus 2i. This one came from x minus 2i. This one came from x minus 6. I do see a conjugate pair, right? Because these always are going to create that conjugate pair. So I definitely want to multiply those together first. Conjugate pairs. What's going to happen with the outer and inner? They're going to cancel every time you're multiplying conjugate pairs. So what's really the only 2 things I need to do? I need to do my first and last. What's my first? X times x, x squared. My last is negative 4 4i squared. Right? So I just skipped the outer and inner because the outer would have been negative 2xi. The inner would have been its opposite, positive 2xi. They're going to cancel each other out anyway, those two terms right here. So what is I squared always equal to? Negative 1. So this really says negative 4 times negative 1. So what am I left with? X squared plus 4. Bring down the x minus 6. So x to the third. X squared times negative 6 is negative 6x squared. My inner, positive 4x. And my last, positive 4 times negative 6 is negative 24. No like terms to combine, and everybody's in the right order. Last one. Number 11. Find a polynomial function of lowest degree, and the zeros that it gives me are the square root of 3 and 4i. If this is a fact, as this is a 0, then so is its opposite. And that one's an I, which means its opposite is also. What are the factors? X minus the square root of 3, x plus the square root of 3, x minus 4i, and x plus 4i. I'm going to let y'all get started on this while I take roll. Here's the order I would do everything. These are conjugate pairs, right? I would do that first. These are also conjugate pairs. So then I would do that. Once I do each of those, because a lot of stuff's going to cancel when you do those conjugate pairs. Once I get those two answers, I'll multiply those together. All right, let me pause while I take roll. Okay, so I'm going to FOIL these together first. So what's my first? X times x. X squared. Now I can jump to my last, right? Because my outer is positive x squared of 3. My inner is negative x squared of 3. So they're gone anyway. So I'll just jump straight to my last, which gives me negative square root of 9. What is the square root of 9? 3. So I'm just left with x squared minus 3 from that one. Same thing over here. X times x. X squared. Since they're conjugates, I'm going to skip my outer and inner and jump straight to my last, which is negative 16 I squared. And what's I squared? Negative 1. So this really says x squared. That turns into plus 16. So we've done those. Now we just need to multiply their results. X squared times x squared is x to the 4th. These are not conjugate pairs, right? So I have to do the outers and the inners. X squared times positive 16 is positive 16x squared. My inner, negative 3 x squared. And my last, negative 3 times positive 16 is negative 48. Your x squareds are alike in the middle. So you're left with x to the 4th. 16 minus 3 gives me 13x squared minus 48. Okay, so we will wrap this one up in the next class.